Hello. Welcome back from lunch. I hope all of y'all had a good meal. So this is Beyond Yocto, exploring Debian for an embedded Linux development by Kotick. I want to say that this was originally slotted as a 20-minute talk, but we were given 45. So we'll have extra time for questions at the end, and that's why there might be some confusion on the schedules. So can we get a warm round of applause for Kartik?
Hi all, good afternoon. So I'm from TI, Texas Instruments. So at Texas Instruments, we focus on open source software, and we always follow the upstream first approach. I'm Kartik. I work as a system software engineer at Texas Instruments for both Citara and Jacinto family platforms. I work on Yocto enabling Debian and also the out-of-the-box applications for these platforms. I've been here for almost 2.5 years now. Yeah. This is a quick overview of the talk. So first I'll give a short intro to what a Linux distribution is, and then a quick intro to Yocto and Debian, and then we'll start with the differences in between Yocto and Debian from a developer's perspective, and then from a customer perspective, and then we'll have the final conclusion, like when to use what and what are the drawbacks of the other stuff. So yeah, a little disclaimer. And yeah, so what is a Linux distribution? So a Linux distribution is basically just a combination of Linux kernel, GNU toolchain, and a specific choice of the init system. It might be systemd or sysinit or something else. The windowing system that you use, the graphical UI, the package manager that you have, and the package repositories that you choose to have, and the default applications. So the choice that you make will become a new Linux distribution that you can ship with a custom name. We have a lot of Linux distributions for a desktop, like for example Ubuntu, Debian, Fedora, and other stuff. So when it comes to embedded Linux, these are the popular choices that we have. So Yocto is a well-used and mostly supported and used Linux distribution. It's not actually a Linux distribution, it's a distribution builder. So each vendor or SoC vendor or platform vendor has their own version of Yocto Project based distribution. So it's a distribution builder, and then we have Debian and also its derivatives. We also have Buildroot and OpenWRT and other stuff, but Buildroot, we'll skip Buildroot and OpenWRT here because Buildroot is mostly focused on building a very minimal file system. It's mostly built to be minimal, and OpenWRT is mostly networking based. So we'll only discuss about Yocto and Debian projects here. So Yocto. As I said earlier, Yocto is a distribution builder. It's a source-based distribution. In Yocto, we just have the metadata to every software component that we have. Like they are called recipe files. In the recipes, all you have is the source from where to get the source of that particular package, and then the revision and the steps on how to compile, what to install, and other stuff. What Yocto does is it compiles everything and on your host and builds and creates a final image that you can flash onto the board. So Yocto is supported by most of the almost all the chip vendors, board and SOM vendors. So if you need extensive hardware support, you can go for you can always choose Yocto and you will have it working. So yeah, this is how the build setup usually looks like. So you have Bitbake, OE Core, and Meta Open Embedded in Yocto. Like Bitbake is the tool that does everything. So basically, it's written in Python. So this bitbake parses all your recipe files and other configuration files and creates your build and builds in your build environment. OE core provides the core functionalities for your image, like the kernel and the bootloader and other stuff. Meta Open Embedded is also by Open Embedded, which provides packages, basic packages which can be installed in your file system. And on top of that, we'll have a vendor specific layer, which is like for TI it is Meta TI and maybe Meta Raspberry Pi and some other layers. So these layers usually have the BSP specific stuff like custom vendor kernel and vendor specific U-boot and other stuff. We usually have in Meta TI, we usually have our TI Linux kernel, TI U-boot and TI Linux firmwares. So yeah, all the vendor specific BSP goes to Meta TI, and then we have file system and other user space component stuff. So you can make your own custom file system layer and include it here. We have Meta Arago, which is a TI owned file system layer, and for other stuff like Qt and Qt and browser, Chromium or Firefox browser, we have Meta Browser and other layers. And also, like for the final product or developer specific layers, you can create a developer specific layer to customize the entire image to your own liking, and you can keep your custom recipes there for your own applications and other stuff. So yeah, build process of Yocto. So in Yocto, the sources are just recipes. The recipes just contain metadata of the upstream sources and how to build that. So bitbake parses these recipes and then clones or downloads the upstream sources and builds it as binary packages. So these packages are IPKs. These can be installed with OPKG, the alternative of DPKG in Open Embedded. So yeah, once you have all the IPK files, and the bitbake then builds the rootfs or the wik image, which you can then flash onto an SD card and boot. So that's a quick intro to Yocto. And when we come to Debian, Debian is a binary based distribution, and it has almost more than 63,000 packages available since I last checked. And yeah, Debian is stable. Debian is known for its stability, and the LTS is supported for almost 5 years. And Debian provides security updates to all its releases for long duration. So yeah, how to build Debian for embedded systems. So we have a clean way to build a Debian file system and an unclean way. So yeah, let's start with the not so clean one. So you can for the rootfs, you can just download any rootfs from the web which is supposed to boot on your specific architecture. Like for example, ARM64. You can download any ARM64 rootfs that will still work, and just boot or chroot to that. And next you can just remove the unnecessary packages. Just a minute. You can just remove the unnecessary packages and install the packages that you need, natively compile any tools or applications that you might need in your final image, and do a quick cleanup, package, clone, and then you can just ship it. But there is a problem with this approach. So the problem is you might you might forget to clean something. Like maybe you might leave your SSH keys in there, or you might leave your proxy setup in there, which you don't want others to know about. So, but this approach is the simplest way to get started if you are just starting with development. And the other method that you have is using an image builder. So for building the base file system, we have tools like debootstrap, mmdebstrap, and bdebstrap. So these take a simple configuration as the parameters or like a file input, which specify the list of packages that you require and other stuff. So you can just build the base file system, install essential packages, add custom configurations that you might need in your image, and then you can even include your own PPA repository to the build, and install additional packages that you might need, that you won't host yourself, and then package and ship. So there are open source image builders like the TI own TI bidebstrap tool, or the BeagleBoard image builder, or Ambien. So Ambien is well supported. There are a lot of community boards that are supported in Ambien. BeagleBoard is just for the BeagleBoard boards, and TI bidebstrap supports all the TI EVMs that we have. So the build process of Debian looks like this. So basically, you just need to give apt the list of packages that you want to install, and apt will just download it from the apt repositories and install it in your rootfs. Then you can just package and ship it. Yeah. So Yocto versus Debian. When it comes to Yocto, getting started on Yocto is usually hard. Like, you need to learn a lot, and you need to set up a lot of environment stuff to start the first build. So Yocto usually have a steep learning curve, but when it comes to Debian, it's mostly simple configuration scripts which you can tweak. Like you can just tweak the packages list, or if you just don't want to do any customizations to any packages, you can just list the packages that you need, and you will have the base image ready. And also for getting the base system, you will have to figure out the layers. As I showed earlier, the meta layers for different components, like meta for if you want Qt stack, you need meta Qt file, and if you need browser, you need meta browser, and those layers might depend on some other layers, like meta browser depends on meta clang. So figuring out this dependencies and also creating your own layer for your BSP is usually hard. You just need to learn a lot of stuff to create your own layer and integrate all that to generate a final image. Whereas in Debian, if you just want to boot on your board, all you can do is just download any file system, just cross compile your kernel and bootloader, modify the image, and you can start working on it. So for application development, once after you have your board booted, it's mostly you can just cross compile the application on your host with the help of Yocto generates an SDK which can be installed on your host PC, on your x86 PC, and you can using that SDK you can cross compile and just run all your applications on the board. So but in Debian, we don't have that kind of SDK. We can still do it with the chroot environment that we have, but the other option is you can do native compilation. Native compilation on ARM hardware will be slow, but depending on the size of application, it might be feasible. When it comes to time to market, Yocto builds take so long to be completed. Like for example, the default image that we ship in TI usually takes 4 to 5 hours for a one build on a server class machine with 64 cores. Whereas Debian, in Yocto it takes so much time because it has to clone all the sources that are required in the file system, and it has to build everything from scratch, including the tool chains. So, but in Debian, it's just all the packages are pre-built and uploaded to the package repositories. All the build does is just just apt install the packages, and you're good to go. So Debian builds usually take less than half an hour for us. And coming to development costs, the builds require server class machines because on an i5 processor laptop with 8 GB RAM, it usually takes me almost 8 to 10 hours for a full build to be done. So it's not feasible for everyone. So you will need a server class machines to build the entire image in Yocto. Whereas, yeah, but Debian usually consumes very less resources compared to Yocto. The build just takes half an hour, as I said earlier. And coming to performance, performance optimizations is possible in Yocto because all the you have all the sources with. I mean, the build happens from the sources, and all the package. In the metadata, what you can do is you can provide custom patches to it, which it will apply during the build. So you can if you have, for example, for Mesa, to optimize Mesa better on your platform, you might have some custom patches. You can just apply those in the recipe files, and when the big builds Mesa, it will apply all those patches and build it. So you will have a fine-tuned, optimized version of Mesa on your image for your platform. But whereas in Debian, it's not usually possible because you will definitely use the Mesa that's uploaded to the official repository. You can build the Mesa package with all your custom patches yourself and upload it to your own hosted PPA, but that's not quite simple to do. And coming to the image size, in embedded we want to be as minimal as possible for the size because of the storage disk restrictions and stuff. So Yocto can be tweaked to be very tiny, ignoring the fact that it will boot or will not boot. You can reduce the number of packages installed in the file system to a very great extent. But Debian essential packages are always required, and you can't really skip those if you want to boot. And coming to kernel and bootloaders part, kernel and bootloader are built as part of the Yocto build. So usually those are present in the vendor specific layers for BSPs, and Debian at least for the embedded system, at least for the image builders that I have shown, for TI BDepStrap we build the kernel deb package and provide it in a PPA repository. But for others like Ambien and BeagleBone image builder, kernel is built as part of the image. I mean, separately out of the image, and U-boot is anyway required to be built outside the image. And when it comes to long-term support, so Yocto releases a new version every year, and all the only releases that are in the 4-year boundaries are usually the LTS releases, and every other release is just 6 months. It is supported only for 6 months. But Debian, we have 5 years of support, and also, yeah, as I said earlier, Debian is known for its stability and security updates. So yeah, when it comes to customers, so TI has been already releasing Yocto-based SDKs to its customers for almost a decade now, and so what is happening is most of the customers who are either automotive or industrial customers, are able to use it because they usually have resources. They are big companies. They have big resources, and be it manpower or the money for the machines and other stuff. But when it comes to small scale customers, it's not small scale customers who doesn't have big teams to work with, and also the hobbyists. It's hard to get started with Yocto for them. So they don't usually need a very optimized output product, but all they might need is just something that works. With Yocto, it takes so much time for them to get everything sorted out. So with Yocto, the small scale customers and hobbies usually struggle a lot, and we get a lot of E2E forum questions on TA forums. So what's TI doing? So yeah, we have this TI bidabstract tool that we started implementing last year. We have been releasing Debian-based SDKs for a year now, and it is built using bidabstract. It's an open source tool. All we have is a simple framework to build a custom Debian image for TA platforms. So what it does is it takes a simple configuration file which you can tweak for the packages that you can choose the packages, and you can add your own PPA to that configuration file and other stuff, and build the rootfs and the bootloader. So yeah, we also we provide scripts to build the Debian package, the TI own Debian packages itself. So the ones that we upload to our PPA, you can just build it yourself. You can modify it for if you have a custom platform based on TI SOCs. You can just tweak those scripts and apply your own patches to the file, to the packages, so that it's optimized for your platform. And TI deb packages is currently where we host our deb packages. And also we have plans to migrate to community projects for better support, because like it's hard to support everyone with a custom tool, because for customers moving from a different platform to TI platform, it is a bit of struggle. So we have plans to migrate to community projects for better support, like Ambien, or we are also exploring other options like ISAR, which is Yocto based build for Debian. So yeah, I'm almost at the end of my talk. And so yeah, when to use Debian? So Debian is mostly useful for prototyping and evaluation. So it's used when it like for example like when I was trying Qt 6 for the first time on TI platforms, it's hard in Yocto. Figuring out the dependencies and other stuff is a lot of work. I almost struggled for a month to get it working on Yocto, but with the Debian, it's just a simple apt install of all the Qt 6 packages, and I'm good to go with the application development itself. And if you are using community platforms, Debian is definitely a very good choice, because they are well supported in the open source. And when you have small scale products or projects, you don't have to waste time with Yocto, because all you need is already available in Debian. You don't need to start from scratch. And for the automated software updates, Debian, with the help of apt, you can just use it without implementing your own version of your own implementation for the software updates. And yeah, as I was stating multiple times, support and stability is a reason why you can be on Debian. So when Yocto is better than Debian? So when the size and performance is an issue for your product, then it's good. It's always good to be on Yocto, because Yocto helps you tweak your images to a great extent. And when you have some custom hardware architecture or custom platforms, it's good to be on Yocto, because you can tweak, and you can fine tune the images to the liking of, to the performance that you need. And when you have multiple variants of images, like for example, you might have 2 or 3 different versions of Linux kernel. Maybe one might be real-time kernel, and one upstream, one vendor-specific kernel, and other stuff. So it's easy to build multiple variants of images in Yocto. And yeah, when it's a large-scale product, you have resources, and so it's good to be on Yocto for that. And before going to software manifest, I'll go with the controlled. Debian, in Yocto, you can have refined software, controlled software updates. Basically, if customers do apt update in Debian, they might break some dependency of your application, and your application may not boot, may not work after that. So you can, in Yocto, you can control the software updates and the software manifest. So software manifest is a file. I hope you all know about that. So so when you want to make a release of, at least in our in TI. So when we have to make a release, we need a software manifest which includes all the packages that are installed along with their licenses, so that customers who don't want, for example, if they don't want to ship any GPL v3 licensed content in their image, they can just check the list in the manifest file, and they can remove those packages. Or, for example, you might have some proprietary packages which you don't want to ship without a legal approval. So software manifest is important for most of the customers to go into production. So what should Debian do? So basically, it's Deb5 helps with the software manifest files. So Deb5 is great. So Deb5, with that, we have machine readable copyright files, so that we can generate software manifest files on our own. But the problem with that is not all packages in the PPA in the official repositories right now follow the Deb5 standard. So, and also, even if some packages follow the Deb5, there are a lot of packages which state unknown as the license for some of the files that they install. So because of this issue, so it basically gets a little difficult when we are releasing a Debian based image, because we don't really know what the license is, when we have to go to the sources of the package to cross check everything. So what can be done? It's just we all have to ensure strict compliance to the Deb5, and I'm not sure if the second one is feasible, like maybe sending a notice to all the package maintainers whose packages are not really compliant with the Deb5, and also a tool to generate software manifest. There are some open source scripts which help you generate a software manifest file, but yeah, they can't really go through the packages which are not really following the Deb5 approach. So yeah, I am personally planning on trying to implement a script or tool to generate the software manifest file in Debian, so that we can go into production with ease. And yeah, that's all. So these are all the references and links to all the repositories that we have, and and also for the Ambien. And yeah, that's all.
We now have time for any questions. If anybody would want to raise their hand, I can come over and give you the microphone.
Hello. I have a question about the packaging format within Yocto itself. I believe that Yocto has the ability to generate packages such as like Pacman packages or Debian packages. I'm wondering if there's anything you've done there in terms of like being able to generate Debian packages from Yocto, and if there's any interaction or interplay or integration between those two systems at the point of Yocto generating Debian packages for consumption into a Debian system or a Yocto system.
So yeah, Yocto can generate Debian packages, but the problem is, they are like you don't have the complete changes, changelog file and other stuff that you will need. So it's just the version that you, it will be the only version of Deb package that you will have. And I personally haven't tried building Debian packages with Yocto, because it is not well supported. It is not well used and it is not well supported. So if you want, I mean, the only thing that's supported well by the open embedded community is the IPK files.
Hi. Thank you for the presentation. I have a question regarding the architecture support. I have checked the TI's repositories and seems like that everything provided is for the ARM 64-bit binaries. Do you have any plans to extend the support for all the TI SoCs which does not support ARM 64 bits and the ones with only 32-bit ones?
Currently, we don't have any plans to support older platforms. All the platforms that we are going to support are K3 based platforms, TI K3 architecture platforms, which are mostly ARM 64. Yeah, so it will be ARM 64 support for now.
Hi, thank you for the presentation. I want to know how TI, since you come from the industry, how does it work with the open embedded community? Like, what's the level of communication or how your proposals go forward if that happens? So I want to know how are you contributing on that side, and also we can make also a comparison to the Debian community. I saw that you have the repos and stuff. How much does your team contribute back, or like what's the level there?
Yeah, so in terms of Yocto, we are, I guess we are a platinum or Yocto gold sponsor there, and we contribute. I mean, we have a big team of Yocto engineers in TI, and they all contribute to the open embedded layers and also the other layers like MetaQt 5 and stuff. So in terms of Yocto, we contribute a lot, but in terms of Debian, we are just getting started. So we have a very small team of developers for Debian, and as of now, we just have we only support the TI BitAbstract tool that we have made ourselves. So we are planning to get started on contributing back to Debian in terms of both packages and platform support and other stuff. So currently, it's very minimal, and for Debian, it's very minimal support from TI. Yeah, because we are still in the evaluation phase. We are still evaluating the customers and other customers and their requirements for Debian-based file systems. So yeah, we'll soon start.
Hello, I have two questions. The first one is there any easy way for users to install their own packages? The other is what's the mechanism to like update a package, for example, the kernel? Thank you.
In Yocto or in Debian? I didn't get that.
Yeah, in Yocto.
Okay, in Yocto, if you want to install a new package, so all you can do is you again need your build environment, the Yocto build environment, and you can have your own recipe there. You can write your own recipe for that particular package, and so yeah, you can have your own package recipe there for that particular package, and you need to build it. So what it does is it will build that particular package and all its dependencies, and then generate IPK file for you. And if you have installed OPKG package manager in your file system earlier, then you can use OPKG to install that IPK file. It's just like DPKG. You can just do OPKG install the IPK file to install that. But the problem here is, so if you have a, for example, if your package X depends on package Y, and you don't have both in your file system right now, if you build IPK file for package X and copy it over to the file system and install it, you will not get package Y. So you have to figure, even while copying the IPKs to the file system to install them, you need to you need to know all the dependencies list that you will require, and copy all of them, install all of them manually to install and use a particular package. And what was your second question?
The kernel update.
Kernel update, yeah. it's the same for the kernel update. You can just get the IPK file for the kernel and install on your file system. So other than that, we don't have any update mechanism. It's just you just need to build your cross compile your Linux kernel, and if you are using an SD card to boot, you can just plug it in and copy all the contents in the file system. That's all.
Anyone else?
Do you do some certification for the products? Do these products go under some certification? Oh, sorry. Do you take these products under some kind of certification?
Certification for?
Software?
For
some kind, whatever?
Security?
Security?
No, I mean, we support security, but I don't guess I understand the question.
Yeah, so you probably work on the development. And that's
Yeah.
And just the last one. How's the support for the OTAs over their updates? Like I have seen some users of Yocto, but they are not TI users. They are the other side, like users of your platforms. Do they have to come up with like the software for it, the tooling for it, or is there something already existing which can be tweaked, or some API can be used for it? It is.
Yeah, TI doesn't support OTA updates in Yocto, so yeah, that's basically it. We don't have support for OTA updates. It's just we release SDKs every quarter. For every 3 months, we release a new SDK with a newer version of BSP and all other stuff. So you can just get that SDK, and if you just want to stick to the current version of your file system and just update the kernel or some other stuff, you have to cross compile, build it, and move it. So yeah, we don't really support OTA.
If that's all, can we give? Was that a question? No. Okay. If that's all, can we give another round of applause to Kartik and thank him for coming out?
On my email, if you have any further questions on how TI does Debian stuff. Thanks.